In the previous videos, we have discussed about how maritime vessels can be likened to floating cities, and as such, it must provide basic services such as the availability of electricity on board. We have also discussed what AC generators are and how it produces electricity. And in the last video, we discussed about how an AC generator is synchronized before connecting it in parallel to an already running generator in order to provide the increasing load requirements of our electrical network. In other words, our discussion so far was focused on electricity generation. Now, the next question will be, how will we make use of this generated electricity? In technical terms, how will we transmit and distribute this electricity to the electrical machineries on board the ship? And this is where our next lesson comes in. In today's session, we will talk about the power distribution system of a ship. To put our discussion in context, let's first understand how electricity is generated, transmitted, and distributed on land, since this is pretty much what we are already familiar with. Shown here is the pictorial representation for electricity generation, transmission, and distribution on land. So kung mapapansin nyo, we have here a power plant which actually generates electricity. So basically, this is the electricity generation part. After that, the generated electricity will pass through a transformer which steps up the voltage, okay, prior to transmission. So, bago niya i-transmit, so papalakihin muna niya yung voltahe, sa kanya i-feed dito sa ating transmission lines. Okay? And then after the transmission lines, pag malapit na doon sa neighborhood or kung saan niya i-drop yung voltages, okay, it actually passes through a transformer once again. Okay? And this transformer steps down the voltage. And this is where the distribution lines will carry the electricity to each of our houses. This is the distribution lines. And after that, yung mga poste ng kuryente na malapit na sa ating bahay, meron din dong transformer, which again, steps down the voltage once again to the usable voltage that is used by our household. Typically, 220 volts. Okay? Sabi dito, transformers on poles steps down electricity before it enters houses. Now, shown here is the transformation of voltages from the generating station to the transmission systems to the distribution systems. As what you can see here, sa generating station, okay, we have 20,000 volts of electricity. And this is fed to a step-up transformer, which basically, pinapalaki niya yung voltahe natin. Makikita nga natin dito na from 20,000, from our generating station na 20,000 volts, naging 345,000 volts. Okay? So, napakalaki na nitong voltahe na ito. Now, the purpose of that is that if you can still remember sa Electro 1, sinabi natin doon that power is equal to voltage times current. Okay? So, voltage times current. So, basically, pag pinalaki natin yung voltahe, we can still achieve the same power but of lesser current. Now, bakit natin kailangan pababain yung current? Because class, as we transmit this electricity, habang dumadaan yung kuryente dito sa transmission lines na ito, okay, there are actually losses. At makikita nyo yan sa bill ng kuryente. We call that the transmission losses. Since these lines, itong mga linya na to, itong mga kable na to, meron yang resistance. Alam natin na pag may resistance, meron yang power dissipation. Okay? I squared R. Okay? The square of the current times the resistance, yun yung power losses natin. And because naka-square yung current, mas malaki yung current, mas malaki yung mass square, okay? Mas lalaki yung power na maloloss natin. Kaya mas minabuti natin na yung voltage ang ating pinataas na value. Kaya naman, it's 345,000 volts. At ito yung voltahe na dumadaan sa ating mga transmission lines. Now, along the way, okay, dadaan naman ito or kukuha yung ating mga power substations, okay, sa mga linya na to, and then it will actually step down the voltage. So sa loob ng power substations, meron tayong step-down transformer, and that transformer, pabababain niya naman ngayon from 345,000 volts, pabababain niya to 4,000 volts, at ito yung i-fade niya ngayon sa commercial or industrial customers. Now, mapapansin nyo, bakit 4,000 volts or hindi naman yan yung voltahe na ginagamit namin sa bahay? So again, this is for commercial or industrial. Yung sa mga kabahayan naman natin, bago yan papasok sa bahay natin, kung makikita ninyo, malapit sa bahay ninyo, merong mga poste dyan. At sa ibabaw ng poste, meron niyang transformer pa din. Okay? So from this particular distribution voltage na 4,000 volts or any other voltage na mas mababa compared sa ating transmission voltage, okay, dadaan pa yan sa transformer para maging 220 volts. At ito ngang transformer na to, makikita natin sa poste ng kuryente na malapit sa ating mga kabahayan. Okay? So that's basically how electricity generation, transmission, and distribution happens on land. Now, what about for ships? Ano yung paraan ng generation, transmission, and distribution on board ship? Let's find out. So shown here is our engine room simulator. And here, we will interconnect what we have learned a while ago to the systems that are found on board. Okay? And we will start with this particular part over here. Okay? Our electrical power plant. Now, shown here is our electrical power plant. Now, notice here that this is where our ship's electrical power is generated, particularly by our shaft generator, the two generators, diesel generators 1 and diesel generator 2, the turbine generator, and emergency generator. We have also here our shore supply, meaning we can take our power source from something that is external to our ship, particularly when the ship is berthed. Okay? Now, if we compare this system to what we have discussed earlier, so this is the system that we have discussed earlier. This part over here, our electrical power plant, is actually related to the power generating station. So again, kung napansin nyo kanina, most of the things that we have seen are actually generators. We have shaft generator, diesel generator, emergency generator, turbine generator. Those are actually talking about the generating elements. Okay? And based on our previous video, alam natin that it will generate 440 volts. So kung dito is 20,000 volts, dito naman is 440 volts. Let's continue our discussion. After na-generate yung electricity, particularly since we have discussed diesel generator 1 and diesel generator 2, so doon muna yung focus natin, saan ba pupunta yung ating kuryente o yung ating na-generate na electricity? So tingnan natin doon sa diagram. So as what you can see here, so we have our breaker. Each of our generators have breakers. Okay? So ito for emergency generator, this breaker is for turbine generator, this breaker is for diesel generator 2, so on and so forth. Now, after this breaker is connected, okay, our diesel generator 1 will now be actually connected to our main bus bar 1. Okay? And we will see later that this main bus bar 1, dito nakakonect yung lahat ng electrical machineries and also our emergency bus bar. Okay? So kung titingnan natin, after yung na-generate na electricity will pass through this breaker, kukonekta na siya ngayon sa main bus bar 1. And after that, okay, so this is going to the shore supply. Ito naman sa diesel generator. So continue lang natin. So after that, we will pass by this another breaker. So kung titingnan natin, tirahan natin. Okay? So kung i-in natin ito, malalaman natin ano tong circuit breaker na to. So this is circuit breaker for the emergency switchboard. So meaning the purpose of this breaker is actually as breaker for our emergency switchboard. So again, after this one, main bus bar goes to the breaker for the emergency switchboard. Then it goes to through here. Okay, and we see this, okay, lines over here. Now these lines over here indicate that when our emergency switchboard, okay, is connected to our diesel generator 1 or our generators here, automatically the connection between our emergency bus bar to our emergency generator will be cut off and will be transferred to this line over here, such that yung load ng emergency generator or yung load na dumadaan sa ating emergency bus bar will be passed on to our diesel generator 1. In this case, our diesel generator 1. Okay, remember that emergency generator cannot, okay, be connected in parallel to our diesel generators. Okay, okay, and we will observe that in this particular simulation. Okay, so we start our simulation. So naka-freeze pa tayo dito. Okay, and if we turn this on or connect this breaker in, okay, notice that this will move. Okay, so that's the automatic transfer. So right now, the load coming from our emergency bus bar is now transferred to our diesel generator number 1. Okay, so again, starting from diesel generator 1, passing through this breaker, the electricity generated goes to our main bus bar. Okay, and then from our main bus bar, okay, passes through this emergency switchboard na breaker, then goes to the emergency bus bar. Now, what is on the emergency bus bar? So on our emergency bus bar, okay, this line over here, malalaman natin that this is our emergency bus bar through this voltage. Okay, so sabi dito, emergency bus bar supply cable voltage. Okay, so itong voltage na to which runs all throughout here. So that's why sinabi natin that this line is actually our emergency bus bar. So connected on this emergency bus bar are the switches for all of these essential services. Especially during emergencies. Okay, we have here our emergency fire pump, okay, and also our emergency transformer, which actually steps down our voltage. So mapapansin natin 440 yung emergency bus bar voltage natin. Then after the passing through our emergency transformer, okay, it became 224. Okay, and this 224 volts actually powers the navigational lights or the light panel for bridge, okay, this one, which are all essential services during emergencies. Now, nabanggit natin kanina na, okay, balikan natin. Nabanggit natin kanina na yung ating main bus bar 1 is actually connected not only to our emergency bus bar, but also to main electrical consumers of our ship. So ano-ano ba itong mga electrical consumers na ito? So we will now go to the feeders and starters. So this is our main switchboard starters. Makikita natin dito itong linya na ito. Na paano natin nasabi na ito yung ating main bus bar 1? Kasi sabi natin kanina yung feeders at starters actually takes its supply from our main bus bar 1. So we have here our voltage once again. So kung i-click natin yan, so makikita natin, okay, this one, that main bus bar 1 voltage. Okay, so meaning this line from here up to here is actually our main bus bar 1. And out from this main bus bar, kumukonekta yung ating switchboard, okay, for our starters. Starters for our fan, starters for our pumps, okay, for our pumps, fans, okay, pumps, fans, compressors, okay, pumps. Okay, ito naman dito is actually the voltage for our main bus bar 2. Kung pansin ninyo, itong main bus bar 2 natin is actually dito kumukonekta yung ating boat thruster at ating deck machinery. Okay? So what about the feeders? Okay? Puntahan naman natin yung feeders. Yung feeders naman, okay, meron na naman tayong linya dito. Okay, so what is this bus over here? So tingnan natin. Sabi dito, it's still the bus bar 1, the main bus bar 1. Dito nga kumukuha yung ating mga feeders. Okay? Which is yung ating steering gear 1, fire station, emergency switchboard, in transformer, or all of these machineries, elements, actually takes its power from our main bus bar 1. Kaya sabi natin kanina, all the main electricity components or electrical consumers are actually taking its power from the main bus bar 1. Okay, so makikita natin dito na our main transformer from 439, okay, coming from our main transformer, naging 223 volts. And this actually powers our light panel bridge, light panel engine room, okay, deck. Okay, these are all yung pinapower ng ating main transformer. Now, let's compare the two. Okay? So, kanina, on our electricity generation, transmission, and distribution on land, napansin nyo kanina na after the electricity is generated, dumaan sa step-up transformer prior to transmission. Okay? But here, kung napansin niyo, after the generation of voltage, okay, walang step-up na nangyari. So basically, okay, our ship does not need transmission lines since itong mga transmission lines na ito, kailangan lang ito kung masyadong mahaba. Okay? All across the country yung distribution or across the country yung grid, electrical grid ng ating dadaanan ng ating na-generate na electricity. But for a ship, since hindi naman ganun kalaki yung kanyang dadaanan, okay, or yung kanyang didistributan, that is why, okay, wala nang step up na nangyari. Okay? So, na-bypass natin yung transmission, automatically we go to the distribution part. At part nga ng distribution part na ito is the main bus bar. Okay, itong main bus bar natin. And then at the heart of the distribution system are our switchboards. Okay, and ito nga yung mga switchboards na yan. Itong main switchboard natin for starters. So starter ng mga fan, okay, ng pumps, yan, compressors, okay. So main switchboard, meron din tayong switchboard for feeders, okay. So these are all the machineries. Okay? And also we have our emergency switchboard.